analysis, which is just basically a fancy word for unit conversions. The reason why it's called dimensional analysis, though, is because we do conversions in higher dimensions, like with square units and cubic units, for example. You don't have to memorize any of these conversions. If these are on a test or anything, then the conversion will be given to you. But it might be nice for you to print these out and have them in a convenient spot to look them up. All right, so first example is you can drive 300 miles on a tank of 15 gallons. How far can it drive on 40 gallons? So in other words, how far can the car go on, or car, truck, or vehicle go on 40 gallons? So we're going to solve it with proportions and with dimensional analysis. So I'm going to make a line here. So over here, I'm going to put, on this side, I'm going to put proportions because I don't need as much room. Let me see if I can spell proportions correctly. Okay, so for proportions, we know that we can do 300 miles on 15 gallons. And notice that the abbreviation for miles and gallon, miles is MI, gallons GAL. You can't just put M and G for those because those are the abbreviations for different units. And then that's going to equal, well, we're trying to figure out how far, so we don't know how many miles we can go on 40 gallons of gas. So remember, with proportions, things have to line up. If I have miles on top here, I need miles on top over here, etc., etc. So this is the only time that you get to cross multiply. And when I do, I get 12,000 equals 15x. Or better yet, 15x equals 12,000, just because I like my variable on the left. So of course we divide both sides by 15, and I get 800 miles. All right, now we're going to solve it with dimensional analysis. So with dimensional analysis, you want to start with one of the values that are given. So I'm going to start with 40 gallons. And I'm just going to put that over 1 to make it a fraction, because with dimensional analysis, we just write everything as a fraction, or it's really a ratio, 1-to-1 ratio with conversions. And one of the conversions that we have for this is that we can go 300 miles on 15 gallons. And I'm trying to figure out how far I can go, so I want to end up in miles, which is why miles went on top. And this way I can cross out the gallons, because if there's the same unit in the top anywhere in the setup as there is on the bottom, those units can be crossed out or divided out. In other words, it's like, since 5 divided by 5 is just 1, gallons divided by gallons is also just 1, so they go away. And now I'm left with the unit that I wanted, which is miles, and I multiply that, and of course I get the same answer. And then, well, we're not there yet, but multiply across the top, multiply across the bottom, not cross multiplication, and it's miles, and then just simplify that, and should be no surprise that we get the same answer with dimensional analysis as we did with proportions. The problem is you can't always use proportions to solve dimensional analysis problems. For example, number 2, a bicycle is traveling at 15 miles per hour. How many feet will it cover in 20 seconds? Can this be solved with proportions? Why or why not? So this one cannot be solved with proportions because there are multiple units going on here. We're talking about distance and time. So proportions will only work if you're dealing with one type of unit. So instead we're going to do some dimensional analysis. So again, start with one of the given pieces of information, like 20 seconds. Okay, so you can put 20 seconds over 1. And we're trying to figure out how many feet. So we want to end our goal, maybe we'll write it over here, is that we want to end up in feet. And that's just to kind of keep in mind. So we know that it's traveling in 15 miles per hour. So maybe we're trying to get to hours so that we can use that. And I know that there's 60 seconds in 1 minute, and that there's 60 minutes in 1 hour. Those conversions were on your conversion tables up above. If you don't already know those facts, then you can write them in on your conversion table. So you'll see that we have some crossing out that we can do, seconds with seconds, minutes with minutes. So now that I have hours, I can use this 15 miles per hour. So I'll want the 15 miles on top and the 1 hour on the bottom, so that hours can cross out. So we're getting there. I'm actually going to erase my goal because it's getting in the way. But somehow I need to get from miles to feet. And there's actually a conversion in your table that gives you the miles to feet. It says that 1 mile is 5,280 feet. So when you feel stuck, go back to your conversions. In this case, we were dealing with miles, so you'll want something to do with length. And you want the conversion that's going to help you get from miles to feet. So at this point, I've crossed out all the units except for feet. So all that's left to do is to multiply across the top. And when I do that, I get 1,584,000 over 3,600 feet. And that's a correct answer, but we should simplify it if we can. And it does simplify down to 440 feet. So what I tell students is to follow the units. So if you are starting in seconds and you're trying to get to feet, you're going to need some conversion in between that helps you get between time and distance. And that, of course, is the given 15 miles per hour in the question. And then make sure that the unit you want is in the numerator and the unit that you don't want goes in the denominator. For most cases, occasionally there's a unit we want in the numerator and the denominator. All right, next example. The recommended dosage for fever-reducing drug for a child over the age of 1 year is 2 milligrams per kilogram. If the child is 1.5-year-old weighing 21 pounds, how much of the drug should they get? So the 1.5-year-old part has nothing to do with this question. I'm going to start with 21 pounds. So pounds is LBS for some reason. Put that over 1. And my goal, I'm going to highlight my goal. I'm trying to get how much of the drug. And it doesn't specify the unit, so we're just going to use the unit that they give us, which is milligrams. All right, so I need to get between, I need to get rid of all my weight units and just be in, weight of the child units and then just be in the weight of the medication. So the child could be weighed in pounds or kilograms, but you would not measure medication in kilograms. So that's a big distinguishing thing here. A milligram is a pretty small amount, and it's a pretty common unit for medication. All right, so I look at my table above and I see that that 1 kilogram is 2.2 pounds. So that helps me get rid of pounds, and now I have kilograms. So I can use the 2 milligram per kilogram, and of course I do want milligrams in the numerator because that's what I want to end up with. Now the kilograms are gone. Multiply across the top, it's 42. Across the bottom, 2.2. And then simplify. So we want to give this child 19 milligrams of fever-reducing drugs. All right, here's one that's a little bit harder than maybe it would be a bonus question. But it's a really good dimensional analysis question because there's a lot of dimensional analysis to do. It says a sewage treatment plant, discharges a pollutant with a concentration of 10 milligram per liter. The plant's total discharge is 250,000 gallons per day. Determine the rate of pollutants released in pounds per day. So start with one of the values that they give you. I'm going to start with 250,000 gallons. And then I need to write it over 1 day here because that's what it's given. And the other thing we have is the concentration of 10 milligrams per liter. I'm trying to get to pounds per day. So down here I'm going to write goal pounds per day. Well, I already have the day part done. I just need to get rid of gallons somehow and make it into pounds. So probably that other piece of information in here is going to be helpful because it's milligrams to liter, which is a weight to a volume. And that's exactly what I need. All right, so it probably would be helpful if I converted gallons to liters, and we do have such a oops, I'm getting some notifications here. We do have that conversion in our conversion tables. If you go back up, so it is going between the metric and the US, but the conversion is right here. So liters, meters, and liters, and what's the other one? Grams. Liters, meters, and grams are all metric. So if you hear one of those, then you know you're looking at metrics. And then gallons, of course, is US. So the conversion is that the 1 gallon is 3.9 liters. So I need to put the 3.79 liters on top, 1 gallon on the bottom, and then I can cross out gallons. All right, so now that I have liters, I can do this 10 milligram per 1 liter, and liters are gone. But I need to be in pounds, so we need a conversion that'll help me get from milligrams to pounds. So that, again, that's going from US to metric, and we're in the weight section. So here, milligrams to pound. We don't have any milligrams to pounds, but we do have kilograms to pounds, or pounds to kilograms. So if I convert the milligrams into kilograms, then I can use that 1 kilogram is 2.2 pounds. You might have to watch this more than once to get it. Okay, so I know that 1,000 milligrams is in 1 gram. Milli means 1,000, and there's 1,000 milligrams in 1 gram. And then there are 1,000 grams in 1 kilogram. That you can get from going back up to the metric units of mass, this one. So the conversions I'm using, One of them's right here. And then I did that a milligram is 1/1000th of a gram. So those are the two conversions. All right, let's see. So grams are gone, milligrams are gone. I'm in kilograms, so I'm almost there. I want to be in pounds. So finally I get to use that 1 kilogram is 2.2 pounds. And then that gets rid of that last unit that I didn't want. And now I have the units I do want, which are pounds and days. So multiply across the top and you get this gigantic number, 208,45000. So 20,845,000. And then the bottom number is 1,000 times 1,000, or 1,000 squared, which is 1 million. So if you divide those two values, it comes out as 20.845. It doesn't say what to round to. And then we just want to make sure we keep our units. That's pounds per day.